Okay, so finishing up what we talked about yesterday. We've got one topic here to cover, one topic, and then a series of examples, and I'll set you free to work on your assignment. We like to talk about, from here on out in this course, is going to be a lot of just relationships with angles and segments inside triangles, okay? And the reason for doing this is if we can learn a lot about triangles end up being the building blocks for other shapes, okay? So every other shape can be made by ultimately a series of adjoining triangles, okay? Even circles, if we really get down to thinking about it, have a huge relationship with triangles, okay, which might not be like real obvious right when I say that. Well, how's a circle and triangle related to one another? But there's a lot of information that parallels from triangles over into circles, okay. So if we can learn a lot about triangles in this chapter, the next chapter, the following chapter, then that will allow us to learn a lot about like hexagons and octagons and other two-dimensional figures, but even three-dimensional figures, okay? So that's kind of where this course is being taken, is to work with a lot of knowledge about triangles. One of those relationships that we like to talk about is the relationship between what we call an exterior angle, okay, of a triangle. So an exterior angle of a triangle, obviously these are all the interior. The three that we talked about yesterday, adding up to 180, those are the interior. If you take one of your segments, okay, so if I'm going from like this vertex to that vertex, if I take my segment and I just keep drawing it off in that direction, okay, I create an exterior angle right there. Does that make sense? Okay. Now, we can do that in a lot of different places, okay? If I have, it's just cleaner for me to draw in GeoGebra. Let's say that I have this triangle, okay? One of my exterior angles is going to go from B, and I'm going to trace all the way through A, and right here would be one of my exterior angles. Does that make sense? Okay. Now that is one exterior angle at A, at the vertex A. I can start at C and go through A, and I get another exterior angle right here. Does that make sense? Okay. Now it has to be where my cursor is now is not an exterior angle because it's not sharing an exterior angle of a triangle. One of the sides of the angle has to be the side of the triangle. So that angle is made by two sides, but they are not parts of the triangle. Does that make sense? But what is the relationship between this angle here and that angle there? They're congruent. They're the same thing. Okay? And because they're the same thing, generally we only talk about one of them. Okay? So when we start talking about the exterior angles of, and really all shapes, not just triangles, we're only going to look at one exterior angle at each vertex. So I'm only going to talk about that one. Okay, and then I could talk about going from A to C, and now I've got that one. Does that make sense? And I'll go from C to B, and I can talk about that exterior angle. Okay, does that kind of look like a, what's the thing? Like they're on a stick and you blow them? Pinwheel. Look at that pinwheel. Okay, and if you start to get, we'll do, so that's dealing with triangles, and I just kind of draw a comparison because we'll see this later on again in chapter 6, I believe, with other shapes. So I can talk about, let's say, four-sided figure. We can talk about an exterior angle right here. We can talk about an exterior there. An exterior angle there, and an exterior angle there. Does that make sense? Okay, so there it starts to look more and more like a pinwheel, right? If I go, say we've got 6 of these. And then we go from F to E, E to J. So these all on the outside would be considered exterior angles. Is that okay with everybody? Okay. But on the simplest form, we've got these here. All right. Now, when we focus on one of these exterior angles, and I just want to look at just one of them, so look at that one. We identify the interior angles based off of that. Okay. This one would be close. Okay. So we don't talk about the one that's adjacent or close to the exterior angle. But these two, okay, we're going to refer to as remote. Remote, and they're inside the triangle, so they're remote interior. What's the word remote mean?
Away from?
Away from something, okay? So I've got a remote control here for my projector, right? It's like control when I'm away from it, right? So I'm far away. If I'm on a remote island, I'm far away from everybody else, right? Okay? So when you're remote, that means you're far away. Well, if I'm talking about my attention being on that angle, then I look at angles 1, 2, and 3. Which of those are far away from the exterior angle? It's 2 and 3, right? Does that make sense? Okay. Now, as I change my angles, so let's say that we're going to look now at, let's cover that up, and I want to extend this, so now this is my exterior angle. Which angles, 1, 2, or 3, which ones there are farthest away from this exterior angle? 3 and 1. Okay, so those would be considered remote interior if I focus on this exterior angle, right? So my remote interior angles are all predicated or referenced off of first identifying what is the exterior angle that you're looking at. Okay, you might have questions on that? Now I've got a question for you. If I take a triangle it doesn't matter what kind of triangle it is. Okay, so that one might look like it's isosceles, but it doesn't matter. And I look at one exterior angle. Okay, so I look at this. Let's call this angle 1 right now. And let's call this angle A. Let's call this angle B. Let's call that angle C. What can you tell me about measure of angle A plus the measure of angle B plus the measure of angle C that we learned yesterday? They have to 180. Good. Okay. What can you tell me about the measure of angle C plus the measure of angle 1? They equal 180, right? We got a linear pair right here with those two. What have we done in the past if these two things were the same? What can I do with these two things?
So we can replace AB with angle 1.
I think I heard somebody say that I set them, they're the same, right? I set them equal each other. Okay. Is there anything, so this new line would be true, right? Okay, these two angles add up to 180, and then these three angles add up to 180, so this relationship should be true. What do you notice that is on both sides here? Measure of angle C. Now, I don't know what that amount is, okay? But I know it's the same in both. That angle C is the same on the left-hand side as on the right-hand side. So let's subtract it, and now you get measure of angle 1, measure of angle A, start with that side. Measure of angle A plus the measure of angle B equals the measure of angle 1. what is measure of angle 1? What was angle 1 for my triangle? What do we identify it at? What kind of angle is it? Is that an exterior angle?
Exterior.
Okay, so we had an exterior angle. And what were A and B for that exterior angle? Remote interior. So what do we just find out? The what of remote interior. I'm going to add two numbers together. What can I call that? Addition. But what's that total called? A sum. The sum of the remote interior is equal to the exterior. Does that make sense? And we've just proven that. We didn't write it as a traditional two-column proof with statements and reasons. We got the statements. We didn't get the reasons, or write them down at least. But we can now convince ourselves, because I didn't use any specific values for A, B, C, and angle 1, and we came up with this conclusion. So that's the new property here that is identified in this theorem. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So an exterior angle is equal to the two remote interiors added together. Is that okay? All right. That's going to be a theorem that from here on out, we're going to see it heavily right now, obviously. But as we move through upcoming chapters, we might see it 3 or 4 times in the next chapter. We might see it twice in the following chapter. We might then see it 6 times in the following chapter, and then once in the following chapter. Does it kind of make sense? So it's going to pop up every once in a while, and it's a nice tool for us to be able to use. So let's get down here and see some examples with this. Okay. So if we have this, and usually the identifier for using that theorem is that there's going to, obviously, they're going to have a triangle, and then they'll extend one of the sides of that triangle, and hopefully that kind of jogs your memory that we're going to use this theorem. So what relationship can we say about 5x? If that's my exterior angle, and these two are my remote interior. What's the equation we can write? Say again. I didn't hear what you said. Joel, what are you saying? Say again. Okay. So is that what you said? Okay. So 5x equals 120 plus x, right? The exterior angle is equal to the sum of the two remote interior. So 4x is going to equal 120. X is 30, right? So if x is 30, this angle became 150 degrees. This is 30 degrees. Now, what would this angle here be? This angle here would be 30, but why? Okay, so we've got 2 reasons. We got it being a linear pair with that one, right? Okay. Do we also have the ability to say that it's a third angle in this triangle? And if I know 2 angles of a triangle, I automatically know the third one? Okay. So those 2 facts allow me to say that that's 30. Does anybody know what kind of triangle that is? It is obtuse. And really, from what we've talked about so far, that's really the only thing you can label it as. But you said isosceles. We are going to, in chapter 4, figure out that this is indeed isosceles. And we can determine that. Even though I don't know any side lengths, these angles right here tell me it's going to be isosceles. And that's what chapter 4 will allow us to investigate. Say, even if not having any distances, because naming a triangle as isosceles or classifying it is based off knowing side lengths, correct? Well, if I have absolutely no side lengths here and no measuring tool, how do I determine it's isosceles from these 2 angles? We'll talk about that in chapter 4, but that's kind of an extension of this. So in chapter 4, we'll see a problem like this, and they'll ask you, based off of this picture, classify the triangle. Okay, well, right now this is kind of the foundation of that, being able to actually find x is the foundation of that, and then we'll build on that later on. Okay, so here we've got a couple different things, right? A couple things going on. What's the number one thing that jumps out at you in this picture?
It looks like the thing on the back of the block.
Huh?
Hourglass.
Looks like an hourglass. You got parallel lines, right? Okay. We got some parallel lines here. If we have parallel lines, of that line, parallel to that one, do we have transversals? Is that transversal? Okay. Now, choosing that one doesn't allow me to solve for x or y, but does it allow me to move this 50 right there? Okay. And that's a game that we might have to play. You're going to, and a lot of people will, and you can address this problem without doing it that way. But a lot of people throughout the rest of the course will say, oh, I should be able, because of the way the picture's set up or the variables that they give me, I should be able to, in my first decision, solve for x or y. Well, you might have to, in order to do that, you might have to move values around to like blank positions, like this angle being a blank position, multiple times before you can actually make a connection between y and x at some point. Does that make sense? Okay, but you should know, even though that's not x or y, you are guaranteed that that's 50 degrees based off our theorems. Okay, so that's nice. What about that segment? Is that a transversal?
Yeah.
What does that tell me?
X is 30.
X is 30. Okay, so done with the parallel lines and transversals. Is there anything else that's going to let me solve for y? Say again? Okay, so these two have to 80. So what's this third one going to be? Got to be 100, right? Okay, if I know two angles of a triangle and I know the total, through subtraction, I automatically know the third angle. So if that's 100, what's angle y?
80.
80. Why?
Because they're a linear pair.
Okay, so those two are a linear pair. But the fact that that's 80, does that also convince you? If that's 80, is that the same thing as the remote interior angles added together? So could I have used that approach too? Okay.
How do you know that? Oh, wait.
What would this angle right here be?
100.
Why?
Because vertical.
Okay, it's vertical with that one. Is it also supplementary with that one?
Yes.
Is it also part of this triangle in which I already know 80?
Yes.
Is it a... I think that's it. That's all the connection you can make with that. Give that one a shot. Do that one on your own. Jigger?
I see that there's two parallel lines. And the transversal, which makes x equal 110.
Okay, why is x 110? What are those two angles corresponding? Good. Okay. So now continue.
Then after that, I realized that the remote interior had to equal 110.
Okay.
So then I just subtracted 40, percent 70.
Good. So y plus 40. Those are my remote interiors added together. They should equal 110. Did anybody say, okay, well, if that's 110, then jump in here and say that's 70? And then 40 plus 70 gives me my 110. And I can figure out what y is. Is that okay? All right. This one's kind of ugly. This one in the past has given a lot of people issues. How many triangles are up there?
1, 2, 3, 4. No,
Five.
four.
Wait, there's four.
5.
This one is four.
No, but the big one. There's a
Okay, so Let's color these. Try to keep track.
The big one?
That's one, right? Is that one?
Yes.
Okay. Is
Okay.
is that one?
Yes.
Okay, so now we're at 2, right?
3,
3
4 high.
4.
is this one.
Alright.
So now what are we at? 4 is
That's infinite numbers.
is this one?
Yeah.
So that's 5, right?
Makes there another big one.
Is this
No. Oh,
6?
yes.
Right? And I don't think we've colored that one yet, right?
No.
So that one's 7. Which little one? Up here?
No, like that whole side is a triangle.
This here?
No,
And then the whole page.
Like all of this?
No!
The left side.
Like just the left side of the triangle.
Oh, like this whole thing right here? We didn't count that one?
No.
Okay, so 8,
No, that's 9.
9.
Oh, that's like 11.
So my point is, there's a lot there, right? Okay, so we should have the ability to, obviously, there's a lot of angles up there that are going to add to 180, correct? Okay, and with problems like this, people don't necessarily always know where to start. Okay, I always make the suggestion, start in the triangle that you know the most about. Okay, so there should be, and there might be 2 or 3 triangles that you know equal amounts about. And basically what I'm saying is, are there any triangles up there that you know at least 2 things about?
Yes.
Okay, so the one with 90 degrees and 25. So you know 2 things about that triangle right there, correct? Okay, so if I look at that triangle, what's 90 plus 25?
90
115, and then subtract that from 180, and I get
65.
65 degrees, right?
Yes.
Okay. Does that help me with anything else?
Wait, where's the X at? Is that on the,
X is
the left?
like this little angle right there.
So, I mean, yeah, it does help because that means the vertical angle.
Okay, so this angle here would be 65, right?
And then you know the supplementary linear theta angle.
Okay, so this is going to be 115,
Yeah.
and that be 115.
Yes.
Is that okay with everybody so far?
Yeah. And then you can figure out the last angle. Oh wait, that's not a triangle, so you cannot do that.
Okay, so I can't figure, so you're saying that angle there. I can't figure that out yet. Well, there is an angle in this quadrilateral that I do know.
The bottom one, that one.
That's 90, right? Okay. Does that make, so now, and then this is that last triangle that we were focused on. Do you know 2 of the 3 angles of that triangle?
Yes.
65 and 90, right? So what's that, 155?
Yeah.
So then what's got to be left over?
You gotta have 30, no, 25,
25?
which is then.
So now so now looking at, oh, what color is going to work here? Looking at this triangle up here. Do you know two angles of that?
Yes. That's 25 and 65.
So that gives me what?
90.
90.
Yeah.
So X is,
Like 110. No, 90.
X is also 90. So X is 90. Y is 25. Do we have the ability to figure out what that angle there and that angle there are?
No. You don't need to. But yes, you probably could figure it out.
Let's do this. Let's see if we do. Let's see if we do. Because I don't know if we do, but I'm gonna call that Z, and let's call this W. What should Z plus W add to?
75.
65.
65, shouldn't it? Should they add a 65? So Z plus W is 65.
You know one guy value next to the x. That's supplementary. At the bottom, like, nothing here.
Well, let's see if we did this. Can I take that angle there, which would be z plus 25. Would you guys agree with that? Plus this angle here. Be 65, right? Plus that angle there.
Which is
25 plus w. What should that total?
180.
180. Does that help me at all? Does that get me anywhere?
Yeah.
So that's 50. No, it still gives me z plus w equals 65. It gives me still the same, when I simplify, it still gives me the same equation. Just looking at that right now, I don't think there's a way for us to find z and w. Okay.
Well, we do know the angle below the x.
Yes, you do know this. So now you know this angle here is 90, right? Here's a question. If that's 90, what's 90 plus 90? 180. What's 65 plus 115? 180. What's 180 plus 180?
270.
360. So, four-sided figure, just added up, when I added all the angles, added up to 360, right?
I thought that was a circle.
We'll talk, so circles have 362, and we'll talk about that later on. But that is maybe a connection that we'll investigate later on and see if right now, based on what we're seeing here in this one situation, four-sided figure has 360 degrees. We'll see later on in the course if that is a common feature for all four-sided figures. Let's do. We'll do one. You want to do this one, or you want to do this one?
The first one.
Do the first one.
Yeah.
What are you going to tell me here about a relationship?
So the 125 is the exterior angle.
Okay.
The bottom left interior angle, remote angle, is
So-
90.
So 90, and then x plus 2y, right? Those are my two remote interiors?
Yes.
Okay, so if I got two variables here, so I can't solve that for x or for y, right? But can I move this 90 over?
Yeah.
And I'm going to write this as x plus 2y equals 125 minus 90 is 35. Is that okay with everybody?
Yeah.
Just put it in standard form that we talked about last year. Okay, and you'll see the purpose of that here in a little bit. But if I can't solve for x or y numerically, that means I need to find another equation, another relationship that is different, and that is going to generate a different equation, but is also still true for this problem. So what is that relationship?
2x plus y is supplementary.
Okay, so that angle there and that angle there are supplementary. So can I say 2x plus y plus 125 equals 180?
Yes.
Can I move that 125 over?
Yes.
So I get 2x plus y equals 180 minus 125? 55. Okay, so we're there. This was true, and this is true. You guys remember taking and stacking these so that they are, your x's are aligned, your y's are aligned, and your constants are aligned, right? And we're going to add straight down. Now, if I left it this way, does anything cancel out? If I add straight down, I get 3x plus 3y, right? I still have two variables, and that's the purpose of this structure, this process, is to get rid of one of the variables. So what do I need to do?
Multiply by
Multiply what by 2?
2.
Top one by -2. Because remember because that's going to generate -2x minus 4y equals -70. And now, because everything was twice as big, it's still the same equation. Does that make sense? Now, can I add straight down? And now what happens to those x's? They cancel. What happens to my y's?
-3.
Negative 3y. And when I go here, I get
1.
negative 15, right? So what's y got to be? Y's got to be 5. So how do I find x then?
You do the same thing but opposite. Or you could just
Well, I could go through that same exact process and solve for x, but there's a quicker way.
plug it in.
Okay, so you go back into any equation throughout the entire problem. Any equation throughout the entire problem, plug back in y. Which one would be the best one to do that to?
Plus one.
I think that one would probably be the best one to do it to. So 2x plus y now is 5. It's equal to 55.
So x equals 25.
So x will be 25. Now we should be able to check, right?
Yeah.
If x was 5 and y was 25, so 25 times 2 is 50, plus x is 55, right?
Wait, what?
Okay, what, did I do something wrong?
Yeah, you flipped.
Oh, I flipped them. I'm sorry. Y was 5, right?
Yeah.
So that would be 10, and that would be 25. So that's 35.
Yeah.
Okay, so that's 35, that's 90. Okay, come back here, 2x plus y. So now that's 50 plus y, so that's 55. That's 55 one, right? Let's see if some features match up. What's 35 plus 55 plus 90?
180.
180. Okay, what's 35 plus 90? 125, right? So we should be able, when we get our values for x and y, plug them back in, evaluate. I mean, we obviously have to evaluate correctly, but we should then see the specific relationships of like exterior angle equaling the sum of the two remote interiors. We should see our linear pair here. We should see the triangle angle sum theorem, and they should all be validated. Does that make sense? Okay. Stop there for today. I'll give you the rest of this time to work on finishing up that assignment. If you got any questions on it, let me know. I can work with you. You can work with one another. Try to keep distance though.